that. And I appreciate everybody being here today, making up some time or carving out some time to talk about really two topics that I'm beginning to become more and more passionate about. Two of my favorite topics at this point: reality capture and digital twinning, I think is a phrase. I have been a member, I am an ex officio member of IMAGINiT's reality capture team. So if you want to buy a scanner, I'm not the guy, but if you want to use scan data, that's where I come in. I work with customers all over the country about how to get the scan cleaned up and get it into their system and to make it do what they want it to do. I do a lot as far as reality capture goes these days. And then I guess this modern term digital twin is something that I've been working with for the past couple of years, seriously, with some of the models that I've generated and then some of the digital twinning simulation solutions that are out there, specifically in way of factory design utilities and the factory design suite. But that's, it's still that idea of working inside of a digital twin. So welcome. I want to make sure that that we cover, kind of the roadmap of where we're going to go today, what we want to talk about. So I think right off the bat, I think obviously we want to discuss what a digital twin is. I think there's definitely an internet definition that's out there, and then there's many other offshoots of what a digital twin could be. We'll talk about reality capture in a couple of different ways. We'll talk about the classic methodology of reality capture, where you go and you want to scan a building and put stuff in the building. We'll also talk about scanning equipment. So kind of the reverse of scanning the facility, we'll talk about scanning equipment and then populating a digital model with scanned equipment models. We'll take a look at, if you're going to do that, how can you clean and enhance these scans so that they work very well in a digital twin scenario. And then we'll take a look, once you have your digital model, what can you do? Once you have this digital twin erected and set up, we're going to explore ideas of process modeling, process simulation in and around a digital twin. And then finally, we'll try to take a step through the computer into the digital world. If you haven't put on the VR headset yet, all right, then you really don't know what you're missing. It's really interesting about stepping into that digital world and looking around and being able to experience this robust real world experience that is the digital twin these days. So there's some new technology that we have that we want to introduce to you. Possibly you haven't seen it yet, in both the simulation and the visualization areas of working with a digital twin. So we've got a lot to go through, and so I'm just going to dive right into it. I think for years we have, if you've been in this 3D modeling game for any time at all right, you've probably run through a number of phases or phrases, and digital twin might be something that's just kind of like the next flavor of the month. I've been modeling now for right about 30 years. And I remember when just the fact that you were doing 3D modeling on a computer was a big deal. And that's what we called it, 3D modeling. But then there was the era of product modeling, where you started to add more information to the model. And then we got into the era of digital prototyping, where we want to put in and build as much into this computer model as possible so that there's no surprises during construction or during the manufacturing phase of a project. And then we got into terms with virtual sandbox. Once we had the collection of models, now we could simulate whole assemblies or whole plants. And we had a sandbox to play in where we can move things around and try to put things in the most logical possible order. And then we got into virtual representations, and now complete virtual simulations. And with technology today at its highest rate, with this idea that so many of the products in the world today come equipped with sensors. Like, how many of you, when you drive your car, how many of you are just reliant, like I am, on that little yellow light that tells you there's somebody in the next lane and you can't merge over? How many of you are starting to look at that light instead of actually looking in the mirror? You know, that sensor is a wonderful, wonderful thing. It's so easy to get used to, but so many of our products now are just completely covered in sensors. And there's so much input out there that we are now actually able to take that sensor information from the real world of a real product and merge that with the digital counterpart and literally create a digital twin that is in some cases updated real time. So this digital twin looks like exactly what is out on the shop floor right now at this moment when it's connected to the sensor data. Now, not all of us are there yet. Okay, I want to make sure on this call you understand that, hey, if you're not at that level of digital twinning, that's fine. You might still be up in the digital prototyping section. That is not an insult. You know, we're all coming to this at different levels. I'll be honest. I don't necessarily throw the term digital twin around a lot. Only in a conversation like this would I even mention it, because you know it's still a brand new technology, and I'll be honest, I'm very good with the products and the software, but you know, merging sensor data and real-time data back into a model like that is something that is still new to me. So we're all at a different level as to what we consider our digital twin to be. But don't worry, you're in the right place, and what we're going to teach you today is going to help, I hope, at all levels of this digital twinning technology or digital twinning world that we're in. I think personally with me, the biggest example of digital twins that I personally work with is in the shipbuilding industry. I am a shipbuilder by trade. I apprenticed as a ship fitter, a steel worker at Newport News Shipbuilding, and I live in Hampton, Virginia, right around the corner from that shipyard. I'm still a major contractor. I still I deliver technical support back into that shipyard, and I work with these shipbuilders. And it is amazing to see what they have done. For so long, they were committed to building a digital version of the ship. And then, you know, I think probably as industries go, probably one of the first groups or first industries to really gain this level of digital twin was shipyards. They were committed to the most important ship at a shipyard is the digital version, because everything is drawn and taken from that thing. But then what did they do? Well, they did some crazy stuff. So on board the ship, on board the physical ship now, you can take a smart device and you can walk up to a bulkhead. And if you look through the bulkhead, or I'm sorry, if you look through the smart device at a bulkhead, you'll see the schematic of all the systems that are located in augmented reality on top of the actual bulkhead. Or you can go to a light switch, and if the right QR code is there when it's seen by your smart device, it'll tell you what circuit breaker and what compartment to find the circuit breaker that controls that particular switch. They've taken all of the information from the digital model and paired it to the physical model to make life aboard ship as easy as possible for the sailors. It's incredible what they're doing, and they're just scratching the surface of merging the digital world and the physical world. Really impressive stuff. Another group that I work with a lot is factory layout specialists, people who are working inside a factory, and they have multiple assets or multiple pieces of equipment that they have to maintain and manage. And not just keep the machines up and running, but they're interested in throughput. How many parts can I get out per minute, per hour, per day, per shift, per year? How can I maximize the arrangement of my facility so I can make it optimal, if at all possible? So, you know, they have factory layout, factory teams, even machine builders have very much embraced this idea of putting sensors all over the machine. So not only do these machines do what they're supposed to do, but they report back to, I like to call it the mothership. And you almost get real-time feedback from the factory floor now as to how things are operating and how many parts per minute, per second is your line producing. So again, amazing to see that the digital world and the physical world are meeting together and feeding each other. The digital world feeds the physical world feeds the digital world. And again, you come back to this idea of maintaining or utilizing a digital twin or a digital copy of your design. Many of you have been doing this process for years. You just haven't done it, to this scale yet. This is a really, to me, it's a personally funny picture. And I understand if you don't recognize this, and I get it. I'll tell you a little story. I was at a car part manufacturer in North Carolina, and this is a former facility. In North Carolina was the furniture belt forever, and many of the factories down there have retooled into doing car parts, on-demand components for automobiles. And I went there and I got to meet the process manager, the guy who runs the entire floor, who arranges all the equipment. And I got into his office, and he had a big conference table, like a 16-seat conference table. And on that conference table was a bunch, I call it paper dolls. There were a bunch of little cardboard, little paper cutouts of the machines and the factory floor. And it was all laid out on this conference table. And there was a little yarn that was going from place to place and Post-it notes about throughput. And this is how this individual envisioned his factory layout. And he was constantly moving stuff around. I had never met an individual or a company that was so dedicated to reorganizing their floor that they could at any point in time move these pieces of equipment around for a more optimal path. It was built in to the systems. And I told him, I said, what happens if somebody comes in here and opens the door and blows this stuff off the table? Are you prepared for that? If the air conditioner turns on and there's an errant breeze, you're going to ruin everything. And he says, yeah, we I don't want to see people. I'm the only one that really comes in here. And this is a very delicate process. But what you're seeing here is that process of these little Post-it notes being placed on a table. And then, as valid as this process is, there's actually augmented reality, where you can now take your equipment and through a smart device, you can place your equipment on top of these little targets, and you can lay out your factory on top of a table. Now, that's not what we're here to talk about today, all right? But it's amazing to see how even the most basic process analysis practices that we've used throughout time are embracing this digital world. And in this case, with augmented reality, to actually see the robots and the machines and the clearance zones that need to happen around all those machines on a conference table, just looking through your smartphone. It's incredible. Another favorite that I love, and this is absolutely true. I went to a shipyard out in the West Coast, was there to teach an inventor class, and they invited me, this group of 10 people, they invited me back to the engineering offices. And I got to the office, and there were 10 little cubicles pressed up against an outer wall. Everybody had a very, very small desk, very cramped. But right in the middle of this big office is a platform, and on this platform is a 10th scale paper model of their shipyard. Every building, every alleyway, every crane, a complete duplicate, a mock-up of their shipyard, and all made out of paper. And I was amazed. I felt like Godzilla in a movie. That it was literally that detailed. It was very nice, very well done. But I asked them, of course, what is this? Why is this here? And they admitted, they were kind of embarrassed, but they admitted it, that, hey, 2 years ago, they had built a unit. They'd sent a unit to a shed to be built. And then after the unit was built, it was too big to get out of the shed. And they had to tear this shed down. They had to spend a lot of money to tear a building down to get the material out. And then they had all kinds of trouble getting this large unit to the dry dock where it needed to go. So to make sure that that never happens again, they built this paper model, and every major unit that they now create gets a paper model, and they take it just like you would a child's toy, and you get down and you walk that unit from shed to shed to shed, or down the alleyways from crane to crane until it lands into the dry dock. to make sure that there's enough clearance so that they never have to tear buildings down again. Now, that's a commitment, folks. That really is. And it's a traditional, practical commitment to having this sandbox that you can play in, that you can see if it's going to work or not. And all of these things we're talking about, all of these things help us predict the future outcome of a particular project, and or to make the best educated opinion possible as to how things are going to turn out. Now, you and I both know there's better ways to build, to gain an access or look in the future than paper models. I think we all understand that. But that's just how this particular team chose to do it. Oh man, when I showed them Navisworks, it was crazy. Oh, it was such a harsh pill for them to swallow that they could do all of this on the computer now. Just so much easier than doing it physically. But let's take a turn to our next topic, which is reality capture. So now that we've kind of agreed what a digital twin is and what it could be, let's jump into another topic I love, is reality capture. So reality capture is everywhere. And if you think for a second, all right, that reality capture is beyond your personal capabilities, you need to think again. If you've got a cell phone, you can do reality capture. If you've got a modern cell phone, like an iPhone 12, it's built in. The LiDAR is there ready to go. It's nice. You know, reality capture usually has centered traditionally on getting a very, very expensive laser scanner out into the field. And I know from a manufacturing point of view, we avoided laser scanners for a long time because they were so expensive. But that price point of ownership has come down to where now organizations have multiple laser scanners. And if you have a laser scanner available to you and you need to generate some 3D models for a potential digital twin, you might want to think about just scanning some of your existing machinery instead of going through the traditional route of, you know, extrudes and revolves and sweeps and lofts or whatever it takes with your traditional CAD system. Why not just skip all of that, scan the components, and load them into your digital twin? It's kind of what we're here to talk about today. But back to reality capture, you know, even hand drawings, all right, if you think about it, hand drawings were a way to capture real world situations. I still see that all the time, where a group will go to a brownfield facility, an existing facility that's going to be remodeled, and they'll go through and just take hand measurements. They'll go back and draw the footprint in AutoCAD. Hey, that works. We can incorporate that into this whole digital twinning process. But again, I think you'll get a more efficient result if you take a high-end laser scanner out there and you measure everything to within a 1/16 or an 1/8 of an inch. And you know that basically you're taking the reality of a space back to the office with you and beginning all of your analysis with the confidence that all of your simulations are going to be based on the reality of a particular space. But I mentioned also photogrammetry. Photogrammetry doesn't really give you the highest resolution of a scan, and it's not going to be the most accurate level of a scan. But in many, many cases, close is near enough. I hate to bring up horseshoes, right? But if you can get it close to the pin, most of the time, that's good. And photogrammetry is getting better and better and better. So if you haven't tried photogrammetry, almost as a homework assignment, I want you to try it. Find an app. I'm going to mention Recap Photo and Autodesk Recap. Run through those things. If you haven't run through them lately, run through them again and see how easy it is to take a scan of a particular piece of equipment and utilize it. Get it into your CAD system and start seeing what's available now. When it comes to scanning, there's a traditional way you approach scanning, a brownfield situation. Again, you've got an existing building and you want to either move into this empty space, or you have an existing space and you want to rearrange the components in an existing space to a better and more optimal layout. And usually when we go and take a high-end laser scan, what the people are after are the traditional structural elements of a building, the walls, windows, doors, all the overhead structure, the floor, and any particular, electrical boxes and electrical outlets and things of that nature, right? They're looking to capture the facility. And in many cases, once you get the scan, then you go through and you clean the scan up and you get rid of everything that's on the floor. And in this particular case, I got rid of the floor too because it was flat and I didn't need to take those points into my CAD system. So we solve, or we use the scan to solve it for the facility. But in doing scanning, I always noticed that I always would come back with the scans and I would see perfect scans of equipment. As I'm scanning a facility, I naturally kind of scan the equipment in that facility as well. And you can take these scans, and instead of looking outwards at the facility, you can look inwards at a piece of equipment. Now, scanning equipment is a little bit different than scanning a facility. A facility is usually a big thing, and in scanning terms, these big things they take multiple scans to get them. And they typically come together and they're stitched together and registered to produce this big thing. And and I'm not going to dive into the weeds of registration, okay? But bigger things tend to register together better than small things. It's a function of the scanner. So when you're scanning smaller things, you take that into account. Smaller things, usually you don't scan as many times. A facility. I've seen facilities that have over 100 scan positions in them, but a piece of equipment might just take 4 scans, one from every, if it's a box, one from every corner. If it's an odd shaped scan, you might need to put targets up so that you have those targets to register when you go to put the scan together. But when you get the scan of a piece of equipment, you get rid of everything in the scan except for the desired piece of equipment. I published this scan. You can actually get this scan in the factory utilities now, and I've had people ask me, why did you leave the barrel on the fork truck? And I just laugh. I don't know why. I just did it. I left it there. So a lot of people, they want this scan, but they don't want the pallet on the forks. Hey, it was my scan, so that's the way I did it. But you have a process for scanning equipment that's a little bit different than scanning a particular facility. So you plan ahead and accordingly to scan what you need. Now I'm going to jump over into Inventor for a second, and I've got scans like this, and I just wanted to share and start off a project with you. So I'm in Inventor, and I'm going to start a factory layout. Now I'm using the factory utilities. What I'm going to show you today is not exclusive to the factory utilities. It's just, to me, I think it's a little easier for me to access this stuff if I use the factory utilities. You can do everything I'm about to show you with just plain Inventor if you want. It's up to you. I think it takes a little more time, but I'm just going to start a new factory layout. And I mentioned the traditional scan. If you have the factory utilities, you can actually duplicate what I'm about to show you. In the factory utilities, if you do a search on your assets with PC, that's not politically correct. That stands for point cloud. If you do a search for those, you'll find some that I've published to the world. One of the clouds I published is a building. It's a traditional scan of a building. And I can, just drag that into my layout here and drop it in place. Now, I'm not going to pay too much attention to the origin point, but in reality, I would certainly want to place this at a particular origin. But for this example, I just want to talk about the scan itself. So the first scan I'm bringing in is the traditional building. So here's the scan that we did, and it's a very light scan. It's not very heavy, but it gets the traditional elements of the building. If I look straight down on it, I can see the orthographic projection of the inside face of this building. You'll see a little bit later, I've added some sketches and some surfaces to it to make it a bit more functional, but it's just a basic scan at this point. And then I want a piece of equipment to bring in. Now I always talk about this little generator, and I'm gonna bring this guy in over here. I'm gonna drop him over here. So here's a generator. I will be honest, this is the first photogrammetry project I ever did with my phone, and this scan's got to be like 12 years old now. So 12 years ago, I could get this kind of resolution with a phone and the photogrammetry capabilities that were promoted at the time by Autodesk. Now, I can actually get much better than this. But this little piece of equipment, I pulled the scanner, I pulled it out and went to my front yard and walked around it and took about 60 pictures with my phone and used a recap photo and generated the point cloud that you see. Reality capture these days in the modern world, it's not just point clouds anymore. You can also get meshes of these models, which is going to be really important later in our conversation, whether you go mesh or whether you go point cloud. It's up to you. I like point clouds. It's traditionally what I used, but when we get into these high-end visualization tools at the end of our conversations, they like meshes, and they're going to eventually support point clouds, but they already support meshes. So keep that in mind. But here is a piece of equipment. Again, if you can imagine, the camera's looking inwards when you're scanning a piece of equipment. And then here's a building right next to it. And you can, again, imagine when you're scanning a building, typically the scanner is looking outwards. And it, again, a little bit different approach to scanning a building versus scanning a piece of equipment. But both are absolutely possible. Now, we're going to come back to this and investigate these components. I want to share with you what the next step would be after the scan. So I want to hop back over to PowerPoint and to just keep on going. We have the idea here of cleaning up our scans. So when you get the scan back, it's going to have all kinds of extra points. You're going to use recap to clean that up. You're going to use recap to align the scan to reality or to the XYZ coordinate system. You're then going to bring it into Inventor. All right. So again, in Inventor, you have another chance to tweak it, make it align to the XYZ axis the best way possible. You want to get it to the 0, point so that, like every other model you've ever created, that scan is at 0, 0. And you definitely want to add all the physical properties. If this component, this model, is going to become an asset in a digital twin, then adding all the necessary property information to the model is essential. You want to add as much information to this as possible. Even things like weight, because this is a scan, it's not going to have a physical boundary. So the physical properties are not going to be available. In Inventor, I can assign this component weight so that it, even though it's a point cloud scan, I can give it the correct weight. I might have to go find a spec sheet and see, or maybe even measure it, what it would be if I put a full tank of gas in this, how much this thing would actually weigh. But I can address all of those things if I'm going to make a scan and use a scan as, in a digital twin. I want it to be as accurate as possible. And folks, if you're photogrammetry, if you've done photogrammetry already, you know that scale is an issue with photogrammetry. You're going to want to make sure this is scaled up as correctly as possible. And I should put that you could scale it up here inside of Inventor as well. It's something else you can do. So you want to make this thing as accurate as you possibly can before you commit to using it in an overall digital twin model. Now, for time's sake, I'm going to hop back over here to my model, and I want to add a few more things to our building. I'm going to come in and add some equipment to our building. I'm prepping to do a digital twin, so I'm going to grab a couple of CNC machines. I'm just going to bring a couple of these in. We want to make sure we've got these ready to go. And again, you could do all of this with just basic Inventor. You don't have to use the factory utilities. But to me, it just It's a little faster for me to do it this way. Let's see, over here, I've got a lathe. Got this LeBlanc lathe that I'm going to bring in. And what's nice about the utilities is you get things like the reposition tool that happens automatically when you bring this in. And I have a vertical mill. Let me bring that in. We'll stick that over here. So whatever machines you're dealing with, all right, these just happen to be a few that I've run across in my life. I'm going to bring in, there's that fork truck. And again, these are all assets you can go download today through the factory utilities. You can go grab these and see how these perform on your machine if you'd like to. So all of these scans in the building came from a laser scanner. So I would imagine the accuracy of these to be within 1/8 of an inch, easy. Maybe 1/4 of an inch. I don't know. It depends on how far it was away from the scanner when it was scanned. But I also have my pickup truck. This is my old pickup truck, my old F-150. I got a really new truck, and I love my new truck. But this is the scan I did of my original truck. It's got if you've ever seen me do this kind of demo before, I'll zoom in and show you. It's got my name on the license plate. I kind of like that. And this is actually not my new truck, but my new truck is the F-150, and it is red. Kind of a burgundy color, but here's another F-150 I did. Both of these are done by photogrammetry. And the funny thing is, the red truck is a toy. It is I can't remember what scale model it is, but the red truck is a toy, and I scaled it up to full scale. And the gray truck is a real truck. It's my old truck. That's the nice thing about reality and working digitally is you can scale things. Here's my wife's car, just to bring that into the mix real quickly. So you got a parking lot out here full of these vehicles, and let's see what else we can get into. Early on, I mentioned some of the earlier scans I did. My neighbor got new windows in his house, and they parked this cherry picker out in front of my house, and that's another one of the early scans. Probably even, I hate to say it, earlier than maybe that generator. But there you go. So everything you see here, all right, the entire facility, the machines that I have in here so far, the cars in the parking lot, whatever you're modeling, all of these have one thing in common: is there's not a single extrude, there's not a single revolve or loft or anything like that I needed to make these parts or to make these components. Many of you are on the call today. You're probably, I know many of you are amazing 3D modelers, all right? Has anyone tried to model a Mini Cooper? It takes a special kind of talent and a special kind of software to generate the surfaces for that object. Same thing with the pickup truck. Or how long would it take you to model a detailed version of a lathe or a forklift? Let's say you're a great modeler and you can knock this out in a day. All right, really heavy duty modeling, you can get it done in about 8 hours. Given that I can go out with my telephone, I could take about 150 pictures of this object from all different angles. I then go back up, I load those up to the cloud, and while it's in the cloud, I can do anything else I want to do for a couple of hours. I get an email in a couple of hours with the model, everything's ready to go, and then I've got the model. So even if it would take you 8 hours to model something like this to a level of detail that you like, you'd be surprised how fast using reality capture can be when you're producing models for Inventor or digital twin or whatever you're working on. Now I'm going to save this. I'm going to save it as sample. And I want to take this one step further. And you'll notice that in many cases, beyond or underneath of the component, I drew a sketch or I added some surfaces underneath of these components. And there's a reason I did that. All right. So it gives you something in Inventor to click and drag on. You can't click and drag on points. There's nothing there. So you have an element in there that you can visualize and move around when you need to. The other is that when I generate a top view, you can't generate views of point clouds. You can't generate drawings of scan data, point cloud data, but you can generate views of these little sketches that you place on the ground. And just so you know, when I traced the Mini Cooper, it took about 15 minutes to trace the Mini Cooper because I can look at it in orthographic view and just trace it very quickly. It doesn't take long to draw an F-150 pickup truck, or it doesn't take that long to draw the footprint of a CNC machine if you're tracing the actual machine. So keep that in mind. It didn't take long to make these assets. But what I end up with, and when I come over here and I want to start a drawing, I'll just grab a standard DWG. I can now generate drawings based on reality. So if I were to come in here and look at my top view, I could very quickly come in and see all the data there. I can have extra data loaded in. I can go in and show the internal sketches and some things like that. But for time's sake, I'm not going to do that. I can come in and, because all of these are now models, all of these are in the digital twin or the digital assembly, I can go grab the parts list of all this data and drop it off to the side, which I get itemizations, I get part counts, I get all that data that we loaded into those assets earlier. I can now manage that and use it for things like purchasing or planning. And, these representations of reality are now elements in my digital world. So things like, if you've ever seen an inventor demo, you're sure somebody's going to make a drawing and they're going to come in and they're going to itemize the components. Absolutely going to do that. But this idea of, what if things change? Well, that again, if you've ever seen an inventor demo, I guarantee you the person is going to take the component and, they're going to move it in position and want to make a change. So I'm going to take and put this in the back of my pickup truck. And there is a tool that you get with the factory utilities. It's really nice. It's called reposition. And it does allow me to just easily lift that up, put it in the truck. So there you go. So I got the 3D looking good. But if I go back over to my drawing, you're going to see that populate in there right away. And, I can now itemize that. Everything's ready to go. So what you're seeing is a complete drawing where I have no 3D models at all. All I have is scan data. But I'm utilizing it in context of Inventor for a factory layout. I could absolutely do the same process and generate or use this as the basis of a digital twin to do advanced simulation. Now, for time's sake, I'm going to jump back over. I need to keep going. I've got a kind of a schedule. I've got a lot of stuff to talk about here. I want to make sure you understand that the factory utilities also run inside of AutoCAD. It's very important for our conversation today. Everything I showed you just now in 3D, I showed you in 3D because it looks cool to show you it in 3D. But for typical analysis work on a layout particularly, you typically go overhead and you just get things laid out. Everything I just did, I could also do inside of an AutoCAD environment. The factory utilities run in AutoCAD Architecture, AutoCAD Mechanical, and that vanilla version of AutoCAD Mechanical. You can run those utilities in there if you want, or you can just insert point clouds the traditional AutoCAD way and do the same thing. Now, what can you do with these models? How can you take these models and really start to take advantage of them? I mean, besides generating a drawing and going to construction and laying out and building the facility. All right, we want to talk about, in this particular case, maybe something like process analysis. Once you have the model loaded, or once you have it, you can then take it and start running simulations on it. And you can start to see what's the most, in this particular case, what's the optimal positioning for all those components. All of the data that's in the model, we can take advantage of that and bring it into our simulation analysis so that we can easily find, bottlenecks or any underutilized piece of equipment. Now, when it comes to process modeling, on my factory utilities, I love the factory utilities. I use them all the time. There is an Autodesk process analysis tool. It is a very simplistic, I would say a very simple level of simulation that's available to you. I think it is here. I will tell you that I know personally this has not been updated in quite a while, but there is, out of the box with no extra fee whatsoever, there is a process analysis tool that's built into the factory utilities. It can be quite useful, but again, it is lacking in some of the more intricate information that you need to really define a process. Now, here recently, just in the past couple of weeks, or honestly, just a few weeks ago, there's a tool called Process Model, or Pro Model. And they introduced a new version of their tool that works right on top of these AutoCAD drawings made of factory assets. It's called the Process Simulator, the AutoCAD Edition. And if you want to learn more about this, if you really want to dive into it and see what is available via the Process Simulator, the AutoCAD Edition, just go to YouTube and type in Process Simulator AutoCAD Edition. Make sure you plug in the AutoCAD Edition. This used to work as a standalone product in Visio, but now it's running inside of the AutoCAD environment right on top of the assets that we just placed. So I've got just real quick, and I'll be honest, I'm only mentioning this as a company. We don't represent Pro Model, all right? But it is such fantastic news in the factory layout environment that this is now available. You can actually get a trial version from the App Store inside of the Factory Design Utilities, the App Store inside of Inventor. But if you bear with me, I'm just going to give you a glimpse of what this tool can do and let you see what a process simulation would look like running on this new digital twin. So if somebody were to ask you, you've got your products that you make, you've got a facility that makes these things. So if somebody were to ask you to increase the throughput, how would you begin to do that? How would you begin to analyze the overall process? Well, typically you want to document your current process, and you want to document it accurately. And that means asking questions like, how long does this particular process take? And some of those answers are not going to be specific. Some of those answers are going to be, hey, it takes between 1 minute and 1 minute 15 seconds. Pro Model has the ability to incorporate averages of time, or I'm sorry, not averages of time. It has the ability to do multiple levels of time when it does its analysis. It's an amazing tool. And now it actually runs inside of the AutoCAD platform on top of these factory assets that I just used. Once you define your process, you can start simulating it, even personnel that have to be present for a machine. You can simulate those, and the tool is smart enough to take into account shift changes, personnel changes, holidays, schedules. All of that information is loaded into your simulation. And before, when I mentioned the fact that you have the idea of multiple time frames for a particular task, what it does is it runs the test over and over and over again with random values for those particular times. And then all of this information is reported back to you in the form of spreadsheets and charts so that you can document your findings and prove to people where the bottlenecks are, where the underutilized machines are. All of that information is available to you, and you can do, again, easily multiple scenarios. You can rearrange the equipment, try different layouts, and see which one best suits the process that you're looking for and which one delivers the better throughput. It is a fantastic tool. I'm so happy to see that this is now running inside of the Autodesk platforms. I've been following this process for about 2 years. I actually got a chance to deliver some training at Autodesk University for Pro Model 2 years ago in 2019. And it was they were working on it then, and that was the idea that eventually we'd be able to have this functionality inside of our AutoCAD platform. And this really does bring the idea of process simulation and digital twinning to the Inventor platform with the factory utilities. Again, time-wise, I need to keep moving on, but now you have the ability to do true discrete event modeling, to analyze your machines and your processes to the point that you can lay everything out in an organized fashion with the times and flow patterns and distances between pieces of equipment all inside of AutoCAD. This is and provides you a great look into the future. Specifically, you're not guessing or you're not assuming about your process anymore. You now have documented what your process is. You've simulated it. You know what the answers are. So you don't make any of these little guesses predicting the future. You make truly informed estimates as to what the future performance of your factory is going to be. You're going to find system latencies. You're going to find underutilized components. You're going to uncover bottlenecks. Yep, you're going to do that. But in the end, you're going to have a crystal ball, and you're going to be able to look into the future and see what your processes are going to be like and make better decisions, more informed decisions based on the simulations that you're running, which is one of the big benefits of digital twinning. All right, I just have a few minutes left before we finish up, and another great enhancement to our digital twinning has been the introduction of a tool called Twin Motion. Now, normally, and I think you saw in that little video I showed you, once your 2D platform is done, like once my inventor work is done, all right, once I have my model done, typically what we would do is take this and send it over to a tool called Navisworks. Navisworks is a fantastic tool. Navisworks is really what I've always called desktop VR. It allows you to step into the environment, walk around it, pick things up and see. Remember I mentioned earlier that shipyard that was moving the units through the spaces and seeing if it fit. Navisworks allows you to pick up these models and carry them and make sure they fit through the openings that they have to pass through. It has advanced collision detection. It's an amazing tool. And typically our factory workflow finishes in Navisworks. Now, I love Navisworks. I love it to death. I've been using it for like 30 years. This tool has been around that long. I used to use it prior to it being an Autodesk tool. But now we can actually take a step further into the visualization side. Navisworks has always looked a bit, I'm going to say, bland. It does high-end rendering, but the default resolution of the images is very simplistic, and it's meant to be. You can have incredibly large assemblies in Navisworks and not bog down your system, but it looks very, very simplistic inside the application. Still use it. I still use it for collision detection. I still use it to record walkthroughs and things like that. But again, just in the past few months, we've introduced a new tool, or a new tool has been introduced to us called Twin Motion. And the thing that's missing, I've always said it with Navisworks, the thing that's missing is I want to step into VR. I think we all have that idea that I just want to put the headset on and jump in here and just start walking around. In our world today, that should be very easy to do. And in the factory design utilities with Navisworks, that is not. Navisworks is not a true virtual reality component. Twin Motion is. So everything I'm about to show you in Twin Motion, I'm going to show you on the desktop. It looks fantastic, but everything is, I could just put the headset on and do it with the headset instead of doing it on the computer. So it is VR, and it's VR out of the box. But on top of that, it also handles large assemblies. So real quick, I'm just going to hop into Twin Motion, show you some of my favorite things. Here is the model. I finished up this particular version. I've got my guys standing around. They're waiting on the parts to start coming out of the factory here. So bear with me. I'm going to do it's going to show you a file. I'm going to do a new scene. I'm not going to save this one. So right away, you start with a cityscape in the background. And I'm going to import my model. Now this import, I want you to understand, when I put my stuff into Navisworks, to get the stuff into Twinmotion, I simply need to export from Navisworks as an FBX file. So that's Navisworks will produce that FBX file, and then I can bring that right into Twinmotion. And this is that. So it is a big model. This is real data, fairly big model. A couple of buildings worth of factory floor that I'm bringing in here, and it comes in, I think, very quickly. Twinmotion is all about visualization and immersion into the assembly. You play it like a video game. It's actually created by Epic. Epic is the company that makes Fortnite and all those crazy video games that you're used to playing. Many of you probably play that. I play Fortnite with my nephews all the time. But it's the same kind of general platform. It's a video game platform from the beginning. You do have a comprehensive list of very high-end materials that you can apply in no time at all. So, for instance, glass. I know I built this model probably about 12 years ago, and I put blue glass in the ceiling so you could see the shadows through everything, and I can now drag that blue glass and just drop it right in place there. I'm going to dive down into the ground level. I'm going to walk in here, and things look very good. The shadows look very good. The blending looks amazing right away. But I'd like to turn the lights on. So I'm going to come down here. There's a material called neon that allows me to just drag this out, and I can drop it right on top of my lights. So again, I modeled that 12 years ago. Now I can actually make it light up. And you can make it do physical lighting as well if you want to. Not a problem. The little characters you saw earlier, I don't know if you've ever seen iMike. If you know who iMike is, he's the traditional mannequin that we use in the factory utilities. We have the factory Stig. I use him a lot. But now you can do things like add animated characters, and this is so nice. I can scroll down. There's a lot of them available. I can grab a worker with a hard hat, just stand him there. And then, of course, I could select him and, oh gosh, I could, right now he's idle. I could tell him, hey, you know what? I want you to sit down on the ground or lie down on the ground or start dancing. All right. I could do those things. All of that stuff's silly. It's built in, but it is extremely nice to see this, this level of realism, and it's so easy to generate this kind of work. And the environment is so free flowing. This, I know on the internet, it might be, as I'm walking through this facility, it might be a little jerky on your end because of the platform we're watching the presentation on. But I remember 12 years ago when I was so proud of these trees. All right. I actually made inventor trees. And I put some water here, and I just, gosh, there you go. Watch this. This is so disheartening to me. Want a tree? There you go. You can actually make a paintbrush, and you can paint with trees in this, and it's very easy to add a bunch of trees to a landscape. Or I can come over here back into materials and go down to water. And if you've ever tried to simulate water inside of Inventor or Navisworks, it's next to impossible. But here you go. It's this easy to make something look amazingly realistic. And I'm going to tell you guys, I can make the cars move around inside of this very easily. I can add realistic cars there. I can add packaging going down the conveyor lines incredibly easy. It's just to get to that level in the time frame we have here, it's just really not possible. But it's amazing to see. Here we go. It's amazing to see how advanced these particular tools have become. There you go. And like I said earlier, anytime I want, I can go right back up to the top and I can load my headset and jump right into VR and be experiencing this in virtual reality. It's ready to go. All you have to do is hook up your headset to the computer and you're on your way. So we've covered a lot of ground today. I feel like I have probably been throwing stuff at you. You probably feel like you've been drinking from the fire hydrant. So I know you probably all have questions about what you've seen. Let me first state this, okay? Before we jump into questions. If you want an in-depth look at anything we talked about today, reality capture, you wonder how I got those scans, all right? Glad to talk to you about that. If you want to look at Process Simulator, all right, from Pro Model, listen, I'll find somebody to talk to you from Pro Model. I have a relationship with them. We have worked with them in the past. We'll find somebody to talk to you about that tool. And if I can't, then I'll download the template and we'll work through it together, or the trial version. Twinmotion, if you're interested in that, but I didn't mention it. Twinmotion is a very inexpensive tool to get your hands on. And I'll tell you right now, the free version of Twinmotion, just as good as the professional. You can use the free version as is and do some incredible work. But if you have questions about what I did in Inventor or the factory utilities, just let us know. Get in contact with an IMAGINiT account representative, and we can set up these in-depth demonstrations or conversations with you about this technology. All right, I am going to come over here and take a look at the questions area.